So last class, we discussed about the applications of stacks. So this class today, we are going to discuss one of the application of stacks. So let me, before get into that, that's application is converting infix expressions to postfix expression and evaluation of postfix expression. So let us first understand what is an expression. So an expression is a valid combination of operator and operands. You may come across with what is an expression means. It's a combination of operator and operands. You can see a star and plus or operators, A, B, C or operands. This also we are familiar with. So what I'm going to explain here means, so whenever these expressions are evaluated in a, so when this instruction is something we give, this is an expression. For example, something S is equal to, we write like this. So how this expression is evaluated? What is the final answer? How do you get the final answer? How compiler will perform means it will not take exactly the same way. What it does means this will be converted into postfix expression and we evaluate this postfix expression, then that will be the final value. That is compiler indirectly translate into postfix notation, any expression, no problem. So why do we need means postfix expression? At the end of this, topic, you'll able to understand how the given expressions are evaluated using the postfix expression. So this is normally what happens. Expression means valid combination of operator and operations, operators and operands. Let us take about the different types of expressions. What are the different types of expression means? So this is the one type of expression which is we are very familiar, that is called infix. So infix notation. So where operator will be in the middle between and we have a operator besides. So we have operands and then we have a operator. So next one is called prefix. So there we have a operator precedes the operand. So this is called prefix. And one more we have is postfix, that is AB plus. So that is postfix notation. So depending on where operator appears, so there we have infix, most commonly we are familiar with, then we have a prefix, then we have a postfix expression. So now we have understood the compiler will convert the expression into this form and then it evaluates this final expression, any given expression to this form and then we'll get the final answer. How we'll understand when you write algorithm, we'll understand. So now let us learn about these type of expressions. And in order to convert from this infix to postfix expression, so we use the stack. That is how the application of stack. And also you think why we need to convert this infix to postfix, already I have told. So whenever we have to evaluate the expression that involves multiple operators and operands, then definitely we are going to use the postfix notation. So that will be understood. So whenever we evaluate an expression, we'll take an example, then you will understand. So let us take now the question. So how do you convert? So whenever we convert an expression means, so first there are common thing. Let us you take simple example. Something I'll write, we'll take later on another, the same example I'll give. So what is the possibilities means? Sometimes we may use a parenthesis and then something -5, something constant, variables. Expressions normally contains constant, variables, operators. That's what we come across. So sometimes maybe like this also. We have operands, variables, constant, and also we have operators. So how this is possibly what we encounter is, one is a operator and then we use the symbol open parenthesis, then we have a close parenthesis, then we have this type of operators and sometimes we may have a constants. So whenever expression is there means infix expressions, possibilities are we have a operands, we have operators, we have a open parenthesis and we have a close parenthesis. So in order to convert this to a postfix expression, that is from infix to postfix expression where compiler needs this postfix notation to find the final value, that is we have to evaluate this final postfix notation, that is also we write an algorithm. Now question is, how do you write this to postfix notation? For that what we do means, already we have understood possibilities, what the expression may consisting of means, if it's a real-time expression, so it may be operator, it may be operand or it may be what we call parenthesis. There are two parentheses, one is open parenthesis, another is close parenthesis. So let us we take so normally what we have to do means the steps followed in this algorithm means examine the input. So first we have to check the each line. So examine the input. The second, so if it is an operand, suppose we got an operand means just you write, we'll take an example. So if it is an operand, just you write operand as it is. That is possible. The second one, so if it is open parenthesis, possibly, so we push into the stack. So then if it is operator means, and we have to look at the stack. The stack is empty. So when there is an operator is encountered, so there are many possibilities. So if it is an operand, just very simple, just you take this operand and we display as a part of output. Otherwise what we have to do means, if it's a parenthesis, we push into the stack. So if it is an operand, there are three possibilities. That's a parenthesis means open parenthesis. So other possibilities are, so if it is operator, look at the possibilities. So when it is operator is encountered, there is a possibility there may be a stack. The stack may be empty. So if it is empty, don't worry, just push into the stack. So if stack contains open parenthesis, then also push into the stack. So if we have already the stack contains operator and we have an operator, so if it has a higher priority than this top of the stack, then also we push into the stack. So these are the possibilities when we encounter with the operator. So when operator is encountered, so look at the stack. So operator means we have to push into the stack. So if the stack is empty, just push into the stack. Look at the top of the stack, what it consisting of means. So if it is as an open parenthesis, just then also push into the stack. So if I have an operator and this has a higher precedence than the top of the stack, then also push into the stack. So otherwise, so pop the top element from the stack, output, and repeat this process. So this has to be repeated whenever we encounter with the operator. The next task is, so if it is a closing parenthesis, if you encounter with the closing parenthesis and successively pop the elements from the stack until you reach the open parenthesis and also discard that open parenthesis. And then repeat these steps until there are no more input exist. So once there is no more exist, remove the contents, operators from the stack and output. So this is the algorithm, this is a procedure, and we'll take an example and we'll be able to understand how this is performed. So let me take an example. So the given example is, let me write an expression which is INFIX expression, and we'll go with this algorithm. So given expression is, I'll write this side. So 2 star 3 slash 2 minus 1 open and close parenthesis plus 5 star 3. So this is the expression given. So convert it into POSTFIX notation. So we do this using manual method, and also we go for what we call using algorithm. So let me use manual method means, how do you do means, first according to the precedence of operator, so evaluate expression which involves this. So that is, you write 2 star 3 as it is slash, so here 2 1 minus, so operands followed by operators. So that is the postfix notation, and write plus as it is, and this is that is 5 3 star. So this is also converted. So now next step, so we have a star, we have a slash, we have a plus. So all has got same precedence. You can, if you want, you can keep it in the next stage. Otherwise you may get confused. Let it be this as it is, because evaluate expression within the parenthesis. That's how we did it. So next one is, so we have a star, we have a slash, we have a plus, we have a star. So star and slash are the same precedence. Then what we have to do, evaluate from left to right. So therefore first evaluate this 2 3 star slash as it is, and 2 1 minus plus, then 5 3 star. So we left with plus slash and plus. So again this has the higher precedence. First evaluate this, then you evaluate plus. So this is 2 3 star, then write 2 1 minus, then the operators slash. Then we have a plus 5 3 star. Now what happens? Evaluate. This is left, this is the right. So therefore 2 3 star 2, 1 minus, right means we have what is right means we have a 5, 3 star, operator is plus. So minus slash is also there, and this is left operand, and this is the right, and this is what I wrote. So this is one part, this is another part. If you are getting confused, the plus is the operator. So what is the final expression? So it looks like this. So 2, 3 star, 2, 3 star followed by 2, 1 minus slash, correct? So 5, 3 star, 5, 3 star, then we have a plus. So we have to write plus. So this is the expression we are going to get it. That is, starting from this expression, we should get that expression. So let us to perform this, we go with the stack. So there is an algorithm examining the next element in the input. So we have a first element in the stack that is in the given expression. This is a string. So it's very simple. Think like a string input. We have an array of characters here. So we have these strings. So first we took this one, 2. So what is 2? 2 is what we call, it's an operand. So if it's an operand, step says just output operand 2. So next we have a stack here also. So whenever we perform this, let me take stack. You know about stack. Right now stack is empty. So next operator, so is star. So what is star now? Let me take this. So star is an operator. So stack is empty means, so right now stack is empty. So I'll push an operator star, and this is how it looks. So this is the top element now, right now. So this is over now. So next element is 3. What is 3? 3 is an operand. So output 3. So next is what happens? Slash. So now look at the stack. Stack is empty? No. Stack has open parenthesis? No. Stack is another operator? Yes. So look at the precedence. So they have same precedence. Therefore, what we have to do? We have to pop it. So this has to perform first, then we have to do slash. Therefore, we remove this slash and then repeat the process. The operator is again, repeat the same step. So now your stack is empty. The push the operator, which is slash. Because we encounter operator already in the stack, so therefore we repeat it. So next is what we have after slash. So we got open parenthesis. So open parenthesis, whatever it is, just push into the stack. So if it is an open parenthesis, push into the stack. Now stack contains topmost element is open parenthesis. Next is a 2, just output. 2 means operand output. So next is a minus. So look at the stack. So if it is an operand, first we have to look at the stack. So if stack is empty, we have to push it. Now stack is empty, no. What is the top of the stack is open parenthesis. Then also we have to push the operator, that is we have to push the minus. So next what we got is, next operand is, next element is 1, which is operand. So operand means output. So next one is close parenthesis. So step number, if whenever close parenthesis encounter, so we have to pop the element successively until we reach the opening parenthesis and discard the open parenthesis. Now, what is the topmost element right now is minus, pop this and output. So next is what is the element? So open parenthesis, remove and don't output, discard it. So this is right now the top element in the stack. Stack contains slash. What is the next operator is plus. So look at the plus is the operator. So whenever the operator encounters, we have to see the stack. Is it stack is empty? No. Stack contains open parenthesis? No. Stack as an operator? Yes. So which has a plus as higher priority? No, it is not higher priority. Slash has higher priority. Therefore, pop. So keep that is it. So pop the stack top of the element and output, and then push the operator plus. Again repeat the process. Stack is empty? Yes. Push the plus operator. So after this we got 5. So what is 5? 5 is operand, just output. Whenever operand encounters, just we have to output. So next is we got operator, so star. And look at the whenever operator means, so we have to look at the stack. The stack is empty? No. Stack has open parenthesis? No. So now stack as operator? Yes. So then look at the precedence when there is operator. So star and plus, which has higher precedence? Star has higher precedence. Then then also we have to push into the stack. So star is pushed into the stack. So next what is 3? So 3 is an operand, just output. So next what happens? Pop the elements. So there are no more inputs. So next pop the elements, that is remove the elements from the stack. So that is star, we have a topmost element, then we have a plus, so empty. So now, so using this stack becomes empty. So which was INFIX expression, so we have 2 3 star 2 1 minus slash 5 3 star plus. The 2 3 star 2 1 minus slash 5 3 star plus. So using this stack, so I can able to convert any INFIX expression to its equivalent or POSTFIX expression. So you might have seen now. So this is very simple. How we do means, so it involves the operation of stack. So stack, this is one of the important, so very important, and this is, when you go for higher studies, you may have to write this program. So we have a practical program sometimes, so you have to develop this one. So whenever you develop compilers for some programs, programming languages, this is a compulsory. So we must, converting this expression for the evaluation. So whenever there's an expression is there and you want to find the solution and evaluate according to the precedence operator means, then it has to be converted in the POSTFIX expression. You can notice in the POSTFIX expression, there are no operators. That is, there are no open and close parentheses. There is only operator and operands. So it becomes easy for the calculation. Look at this. So we have this starting 2 will be the operands and this becomes operator. That is the next topic we'll discuss. I think now you have understood. So how this conversion of INFIX to POSTFIX expression works. So very simple, examining the next element in the input. If it is an operand, just output. So if it is possibilities, if it is an operand, output. If it is an open parenthesis, then push into the stack. So if it is an operator, there are 3 possibilities. So if it is an operator, look at the stack. What are the, when at all we push into the stack means, if stack is empty, operator has to be pushed into the stack. If stack contains the topmost element of the stack is open parenthesis, then also we push into the stack. If stack contains operator and we have the operator which is higher precedence than the top of the stack, then also we push into the stack. Otherwise, we pop, we repeat this process. So this is what we do when we encounter with the operator. The next, if it is a closing parenthesis, we encounter means, so pop successively until you reach the open parenthesis and output, that's it. And repeat this process for all the elements. When there are no more element exist in the input, then whatever the contents in the stack pop successively and output. So this is a simple algorithm. This is how we use algorithm for convert. That is converting from INFIX to POSTFIX notation. So maybe in exams they may ask, write an algorithm to convert from INFIX to POSTFIX expression. This is how. If they don't ask in the exams also, but when you go for higher studies, when you study in the computer science or data structures, this is the basic. So this algorithm or this programs we may be writing the functions, how to convert this INFIX to POSTFIX expression. So I think it's very simple, just you make it as a string and you check whether it is an alphabet or special operator, include only star plus minus. Then if it is there means a very simple one to implement, it's not difficult at all, but you must know how this is done. If you know this sequence, very simple, converting to that one. So this is something about the conversion of INFIX expression to POSTFIX expression. So next one more application of the stack. And also there is a question. So why do we convert to like this form? So already I have told the answer is, so look at that expression and this expression. What is a difference you can make out is very simple. There is, in this expression, there is no open and close parentheses. They do not operators. They do not have any values. So therefore, we do not need them. So we have to eliminate. But what they have some precedence. So we have some priority. So therefore, we have to maintain. So this is the expression which includes only operands and operators. So if there is an operator means there is succeeding will be 2 operands. So that is how we have to do. So now if it is, now what I have to do means I have to evaluate this expression means then again also we use a stack. So what I do in this case means, so I'll take this operand and I'll push into the stack. So I'll keep repeating pushing the stack until we encounter the operator. So when operator is encountered, so that is its 2 operands will be on the top of the stack. So pop these 2 operands and perform the operation, again push into the stack so that it becomes the operand for the next operation. Then again you repeat this process. And So whenever we do like this means we repeat for all the elements. So that is the final value will pop from the stack. So what is the main concept associated means? So the concept, because in postfix notation, what happens means the operator always preceding the operand. So you can see here, so we have first operands and we have a followed by operator. So therefore whatever we get first, they become operands. So we have to push into the stack until we encounter operator. So once operator is encountered, so pop the top two elements from the stack, perform the operation and again push into the stack. So that becomes the next operand. So repeat this. So until there exist all the elements, that is in a postfix notation. So when there are no more elements, pop the answer from the stack. So what will be the final, the content will be the stack contains the final answer, pop the final answer and produce. So now let us rewrite an algorithm for this. It's very simple, evaluation of postfix notation. That is how do you oh sorry, we need this one, otherwise it is there also, no problem. The same we'll write. So what is the algorithm says means? Let me write while, so when there is this expression, while there exists more, while there more input exists, that's like this. While we can use while more, this is more input exists. So this is, you can use, if it is a array means, so it is, you can write like this. So if it is an array, so slash, so that is while some string str of I not equal to null character, that is while more input exists, do the following. So what we try to do means, first we have to check, so what is the symbol, first what we will get. So if it is, if some symbol we are using, if symbol is, so if it is an operand, so we have to check it's a plus, minus or just excluding that. If it is not operator, so if it is an operand means, so that's what we have to do. So if it is operand, if it is an operand, so then what we have, so that's actually, so then let us take if it's an operand. So let me write here, if it is, so if it's an operand, so what we do, we push this into the stack. So we'll take the same, we'll be evaluating, then you will be able to understand clearly. So what we do means, we have to push into the stack. So push, already we have learnt algorithm. So there, so let us, we'll just operand stack. You can use anything, stk we can use. Then you are pushing this symbol, so sym. So else means, so whenever I said if it is not an operand, so whenever it's operand means we push into the stack, like if it is first 2, then 3. But now we got an else, that is we got operator. Then what we do means pop this and pop this, perform the operator right now with the symbol. So what is the first one? So we'll take operand 1 will be pop from the stack, that is pop. What is 3 will get, that is that the pointer you can use stack, I'm writing, just you write stack, that is the operand stack we can use. From that we are popping the element, so that you can, if you want, you can write, that is operand stack is like a top pointer. You can write this one, operand, the same top pointer from the stack, indirectly from this stack we are popping. So similarly, pop 2 operands, but every operator is associated with 2 operands. Therefore, pop the second operand, it is from the same stack. So stk. That is first 3 we popped and then we popped 2. So it is, the operator is now symbol. So what is that operation we do means? So we do some operations, the value you can write will be, so operand 2 first, and then symbol is a operator now with operand 1, sorry, OB, operand 1. So we got the value, this value again pushed into the stack, that is pushed into the same stack, push, now same, what is the tag, OP stack. Now what you are pushing, the value, so value is a new value calculated, and repeat this process as long as this exists. Otherwise, we'll take an example, you'll understand. So after performing this, when while loop becomes false, so pop the operator. That is, pop some value. You can take any variable, the expression value. The value is final value. Or result you can use. Use result, any variable name, result equals. So we have to pop from the stack. Which stack? The same stack which is OP, pointed by OP STK. So this is how the expression is evaluated. So this is an algorithm for evaluation of the postfix notation. So how do you evaluate means while more input exists like this, take example, we'll follow this and do these operations. This is while end. So between this is what we have to do. At the end, after completion of this, just pop, that will give you the final answer. Let us follow this procedure. What is the final answer we'll get, or we'll take other examples also as well. So first one is, let me now take an example. This is we want a stack, let it be stack. It is named by OP STK, that's a top pointer. It's like top point. Using this we are operating. So stack operand, it takes, if now we take some symbol that is 2 now. We are taking the element. While more input exists, we take the symbol. So if symbol is operand, so if it is operand you can use. Symbol is operand, something like this. That's a program we have to do. Just symbol is operand means then what we do, we push into the stack. Yes, 2 is an operand, hence we push into the stack. That is, it is pointed by now, OP underscore stack. This is a stack now, so it's a top pointer. If it is a pointer means this is how we perform, top. Next what happens, take the next element, 3, while, repeat again, exists 3. After 2, it is a 3. So 3 is an operand, yes, push into the stack. Just I'll write, I'm not using this top pointer. So you remember, this is how normally it works. Assume it is a top pointer, correct. Next what happens, still more exists, repeat now. Yes, we got now what is the input, now we are taking, next input is star. Is it operand? No, else means pop. So what is popping now? Operand 1, so I'll write here. So OP1 becomes here. So what is OP1? 3, pop from the stack. So next, pop the operand second. So OP2 becomes 2, which is pop from the stack. So stack is empty. Then we got value. It is a calculated. Now new variable, value will be, so it is operand 2. What is operator? Star. 2 star 3. That is 2 star 3 means 6. 6 will be passed into the stack, pushed into the stack. So this is 6. So that it becomes the next operand. So that's what we do. That's how we did it here. Since it's simple, no? So 2 into 3, that's what we have expression. Multiply. So 2 into 3, that is how we did it. It is pushed into, so next it becomes the operand for the next operator. So now get into the next one is 2. So what is 2 now? Sorry, what is 2? 2 is an operand. So if it is an operand, just push into the stack. So 2 goes to the stack, top element. Then again go to the next element like I++. We go to next 1. 1 is again operand. It's also operand. Then also we push into the stack. So therefore, the 1 becomes the topmost element of the stack. Then we goes to the next element is a minus. So whenever minus encounters, that's the operator now. Is it operand? No, else. So pop the top 2 elements. That is operand 1 will be 1. We got 1 here. So operand 2 will be, this is removed, the second pop. So will be 2, same. So top is right now here. So what is the value now? So it is operation 2, symbol is operator now minus first operand, it is 1, correct? So operand 2, which is 2, my symbol is minus and operand 1 is 1, the value is 1. So therefore 2 minus 1 is 1. So this becomes, value becomes 1 and thus it is pushed again into the stack. So push that value into the stack. So now topmost element contains value 1. So what is the next one is, we get a slash, correct? After minus, we got slash. So whenever slash encounter means, again, pop the topmost element, top 2 element from the stack, perform the operation. So what is the first element? Operand. So it becomes, so minus 1 was there, no? So next is slash. So slash, we perform, what is the operand? First one is 1, second one is 6, correct? So value will be written as operand 2, that is 6 divided by 1 this time. We remove this 2, so operand 2 by operand 1, so operator is slash. So 6 by 1, so you will get 6 value and that 6 will be pushed into the stack. So again stack contains the topmost element is 6. Next let us see what happens. After this we got 5. So if it is an operand, push into the stack. So 5 will be pushed into the stack and top goes to the next place, top plus plus. So next again we get the next element from the stack while more exists. Yes, more exists here. So 3 is again operand, push into the stack. So top becomes topmost element. The next is we got an operator. So now what we have to do? We have to pop. So else pop operand 1 is now 3, first one. 3 we popped, operand 2 is 5. So perform the operation, operand 2 into, now we can see 2 symbol 1. What is 2? We have 5, so it is 5. Operation is star and then it is 3. So 5 into 3, so 15. So this is we have removed 5, 2, 3. So 15 is pushed into the stack. So top element now 15 after this, correct? So go to the next. So after this what we have? Plus. What is plus? Again pop the 2 elements. So the plus is the operator now. Plus is the operator, so pop these 2 elements. What is the first element? So we have an element 15. Then second element is, what we have is 6. So it becomes plus 21. So push into the stack. Is there exist any more elements? No, we stop, we quit. That's a /0 I wrote, null character. This is an expression now, POSTFIX expression. So then finally result will be pop the stack, which will be 21. So our result answer is 21. If we evaluate according to your procedure only, let us see how it works. So we have known this one, the same thing, 2 into 3 / 2 minus 1 is 1 plus 5 into 3. This is the procedure. Evaluate. So now we have multiplication slash and star. So multiply first, 2 3s are 6 divided by 1 plus 5 3s are 15. Correct? Now plus and slash, so 6 plus 15. So what is 6 plus 15? 21. So what we got, the answer is 21. This is algorithm. This is how computer can does it. This is how we are going to do it. I think you have understood now the need of. So when you have an expression like this, the compiler will not do like this. As human, we do it like this. Because we understood this slash, we do not consider for calculations. And also we follow star, plus, minus, and division precedence. But here what happens, computers don't know what is this operator, what is this slash and all. So just we have to do mathematically. This algorithm will follow the same precedence. So there we have a application of stack. So we have understood the application of stacks. One is the evaluation of, that is the conversion of INFIX expression to POSTFIX expression, and also the evaluation of POSTFIX expression. So this is this is how computers, so whenever you write s into s minus a, s minus b or something, we write some long expression which involves a multiple operator and multiple operands. Still how computer can perform this sequence of operators along with operands correctly means because of this one. So this is how it is never going to mistake. Well, it is the operator and operands in the form of POSTFIX notation, which will be from INFIX, and it is converted into POSTFIX, and then using this algorithm, the use of stack. So you might have taken the importance of stack. So whenever we explain stack, you never thought. So it's arrangement of one abelian. So we do not know how it's one of the importance. So how your expression is evaluated because of the stack. That is why I said stack is more important data structure. You'll understand, and it becomes necessary whenever we go for higher studies. You'll know. So you'll be implementing these type of programs in the lab. Maybe it's also you can try also in the right programs, convert this algorithm into program. but it needs a little bit, that is, make it as an array, it's also an array, and then use this operand or you change this operand, so use the switch operators, compare with plus star or something, and then you push into the stack, otherwise perform this operation. Simple things, again push. So you should know how to push operation, how to pop operation, and this calculation, simple things. So you can easily write and it will find the final answer. So this is something about the application of stacks, which is more important. That is, practically we use this in whenever we use computers. We have this. That's why I'm saying stack is important. That is, evaluation of expression INFIX to POSTFIX, and then evaluation of POSTFIX expression. So that is something about the evaluation of expressions. There are some examples given, and you can try for yourself. And also they have given some example for POSTFIX. And you take one more example they have given, that is, they have given convert the following expression into POSTFIX expression. Expression is a plus b into b star c. So use the same method which I explained in the algorithm and follow this procedure. And you have problems if you are not able to get the correct answer. So let me know that, so I will repeat that question. So very simple one, so no need, just you also practice. Just follow what I said in the algorithm. So whenever, so it is evaluation, I'm not asking evaluation, conversion, examine the next element in the input, and then we push into the stack. So there is, if it is an operand, just way out. So if it is a open parenthesis, then push into the stack. So if it's an operator, and when at all we push into the stack means when stack is empty, we push into the stack. When stack is as the topmost element is open parenthesis, then also we push into the stack. When it has higher precedence than the top of the stack, then also we push into the stack. Otherwise, from the operator, output, repeat this step again. So repeat this for all the elements, and finally of the element. That's how we convert the INFIX to POSTFIX. That we have an example that we do as an exercise assignments. There are two problems. Yes, there are two problems. You can do it. And also they give some examples. So INFIX expression to prefix. They give a plus b minus c. So something like this. So we talked about post expressions. So let me some examples how prefix can also be done. The same problems we have other two. So you try that POSTFIX evaluation. Some problems are given that also you can try. So now we have a plus b minus c. So we have to convert into prefix. So prefix means already I told you it's an expression a plus b means plus a. So the same thing. So same precedence, evaluate from left right. So plus ab. So then we have minus then. So this becomes a left operand, this becomes a right operand, this becomes a operator. So therefore minus left operand plus ab, and what is right operand? C. So this is how we write prefix. So we take one more example that given, that is a plus b star c plus d. So one more problem is right here a plus b parentheses are given star c plus d. So what happens here is we have to follow the precedence of operator. So star is minus, we have to do precedence because we have included parentheses. So parenthesis has to be performed first. So therefore it is plus left and right. So left operand A, right operand B. Same, that will be right star as it is, and here we write that is plus C D. So operator and then left and right. So now this becomes left, this becomes right, this becomes operator. So take operator first, star plus AB, then this right plus C. So like this, I will give some examples to practice. If you have a doubt, let me know. So simple things, but now there is a lengthy one they have given, use the parenthesis and precedence of operators. Take it as an assignment. Then you do it. Then you understand clearly. If I show all those also, then what you will understand. So maybe you try, you will get it definitely, but you must know this basic. That's why I give you the idea. And you have simple methods. Do it. Take precedence of operators like parenthesis first, then star, then slash, then addition subtraction. Follow those ones. So there was same precedence evaluated from left right. So this completes about the stack. So then we have a cube. The cubes will be maybe if I start so we'll start in the next class. What is a cube? Types of cubes, like another linear data structures, what are the operations performed with the cube, and let us we learn the application of FQ and also we learn the algorithms, the insertion deletion, that NQ and DQ algorithms, and we learn all this in the next session.